Hi, my name's Dan. This video is one in a series that I'm doing on AI in Unreal, and this is part of a rolling example. In this one, we're going to start getting some realistic sight behavior for the AI character that we've got. So let's have a quick reminder of what it is that we're trying to achieve. So the AI character is going to stand on the spot, and if it can't see the player, it'll keep turning around looking in random directions. So every few seconds, it will turn and face in a different direction looking for the player. If the AI character catches sight of the player, it will stare at them. So as the player moves around, the AI character will rotate on the spot, but keep facing the player as if it's watching them carefully. Once the AI character has had sight of the player, and if they then lose sight of the player, so if the player goes around a corner or something, the AI character will then move to the last known location of the player. So it'll go to where it last saw the player. And then once it gets there, it goes back to looking round if it can't see the player, or if it does catch sight of the player, it'll revert to the staring. So that then starts the cycle once again. If it loses sight of the player again, then it will again move to the last known location of the player. So where have we got up to? Well, we've got the character that we're going to control. In fact, we're just going to turn her around a bit so that she faces the player character when play starts. We've got an AI controller, which will be controlling her. We've got a behavior tree, which will give us the behavior. We've got a blackboard, which has got a variable in it, which is determining whether she can see the player or not. We've got a service here, which we set up to randomly change between seeing the player and not seeing the player. So that's where we're going to do some work this week. Not this week, this session. And in this, we've also got a task here which just reports back to the player. So let's open up the service. So in here, at the moment, that key in the blackboard, which is called Can See Player, is being randomly switched on and off. What we need to do is just to get rid of all of this, and we're actually going to implement sight whether she can see the player or not. So what do we need? Well, we need a reference to the character, which will give us the position of the AI character. So the owning actor here for the AI is on the spin. So cast to okay, and it's actually the controller that we're going to need to cast to, and then we're going to take it as the controller. We're going to get control form. So that gets us the actual AI character. And what we're going to want to do is, first of all, is to see whether there's anything in the way between the AI character and the player. So to do that, we're going to draw an invisible line between the AI character and the player. So we need the location of the character and the location of the player to be able to do that. So I'm going to do get actor location. And what we're going to do is call the line trace, which traces this invisible line. Trace. And the one that we want is line trace by channel. There we go. And so we're going to start the line where the AI character is, and we're going to take the line to where the player character is. Player character. So we're going to get the player character and get their location as well. So location. There's location. There. What that line does is it starts at the AI character and traces through to the player character. But if anything's in the way in between, it creates a hit. So if the thing that it hits is the player character, then the AI character can successfully see the player character, and if not, then there's something in the way. Okay, so we need to use what's called the camera trace channel. I'm not quite sure why, I confess. Now, there's a thing down here which is ignore self, which is useful because actually you're starting this line from inside the AI character. So the first thing it meets is in fact the AI character. However, ignore self. Self is not actually the AI character because we're doing this inside a service rather than inside the character. So what we need to do is to tell it to ignore the AI character. Now, the easiest way to do that is to feed it into this pin here, which is actors to ignore. And you can give this line trace a list of things that it's going to ignore. And it expects an array here. So the easiest thing to do, actually, is to get all actors of a class and to use that AI character class, STLK character. And that gives us an array which has only got one element, but that element is our AI character. And if we added more, then it would ignore other iterations of the AI character if we had them in there. So this gives us the line trace, and our hit result comes out here. So we're going to break that to get information out of it. Break it and expand that. And what we're after is what is the thing that it's hit in the line trace. And so we need to check if that is equal to the player character. Tell you what, let's have a new node. Get player character. So at this point, this Boolean that comes out here should be true if the AI character can see the player character, if there's nothing in the way, and it should be false if otherwise. And that's exactly the information that we're wanting to put into this can see player blackboard key. So we're just going to drag that across and set blackboard value as bool. And we can just plug that one straight into there. Okay. So I just need to check all the execution stuff. I think I've left one. No, I did. Plug that one and get all acts of the class. So hopefully this will now control the behavior. Now, if you remember, inside the behavior tree, we've got it so that it's just saying, where are you if it can't see you, and I can see you if it can. So let's see if that behavior is correct, and it's what we're expecting. So we have had at the start just one, where are you, whilst it gets itself going, but now it's saying it can see me, and that's fine. Now, if I walk behind it, it can still see me, so it's got eyes in the back of its head. We'll fix that in a minute. But if I go behind a block, it's switched to where are you. Okay. Now, there is something that we kind of demonstrated there, is that I can see you. It doesn't respond immediately. It's a little bit slow in responding to seeing and not seeing. And we're going to fix that. It's fine, there's not a great delay, but actually, let's demonstrate that a bit more clearly by changing this delay in both of these, not 30 seconds, 3 seconds, isn't it? To 3 seconds. And in this case, so we've got where are you, which is the first one, so it can see, so that's fine. And as soon as it says I can see you, I'm going to run around and hide. And I can get quite a long way around before it seems to have realised that it can't see me. I'm just going to do one more, where are you? And I'm right in front of it, and it hasn't noticed it can see me. And the reason for that is because it's running through that behaviour tree in a kind of in the way that you expect, and it's stuck on these delays. We can make it respond faster to the change in condition there by getting into these decorators, and instead of just leaving it to check as it comes down, it can actually jump out when there's a change in that value, and a change in the value is not set. So you've got notify observer on result change, and we're going to do it to self. I know that setting it to self in this situation works. What I don't know is what lower priority in both means and how that works. I know that it works this way, so I'm sticking with it. So let's have a quick look at that. So I've got, I can see you, and hopefully as soon as I hide, where are you? As soon as I appear, I can see you, where are you? So I can make it trigger backwards and forwards quite quickly. Okay. It still can see me if I'm standing behind it, so another thing we're going to do is we're going to introduce a sight cone, and I'm going to make it so that, so obviously straight ahead is 0 degrees, and as you go around, you think about the angle of how far around you've got, and that's 90 degrees. I'm going to make it about 60 degrees, which is about here. Okay. So let's do that. What I'm not going to do is spend ages explaining what I'm doing with this sight cone. I have done a series of videos on how to use vectors, and doing a sight cone is in there in the using the dot product, which is what we're going to use. So I need to get back into here. So there is another video on this. Go look at that if you need to. Hopefully you'll have some understanding of what I'm doing. So what we want is two vectors. We want the vector that represents the direction that the AI character is facing. Excuse me, and we also want the vector that is the direction between the AI character and the player character. So we'll start with that one. In fact, we know the location of the AI character, which is this one. We're going to get the player character. We've got the player character location here as well, so why not use that? I'm just going to pull it up here so that it's kind of out of the way, and I'm going to put a reroute node in. So just by typing reroute, and I'm going to do minus vector by minus vector. So the vector from A to B is the vector of B minus the vector of A. So that's going to give us a vector from from the AI character pointing in the direction of the player character. And we need to normalize this vector to make it unit length. The other vector that we want is the direction that the player character is facing. So we're going to pull off from the control pawn here and do get forward, so get actor to forward vector. And just in case that's not a normal length vector, we're going to normalize it. If these terms don't mean anything to you, go and check out my series of videos on using vectors in Unreal. So we want we want to find the angle between these two. The way to do that is to use the dot product. So dot products, in there, and then we're going to turn this into degrees. So we're going to do the dot product of two unit length vectors gives us the cosine of the angle between them. So we're going to do a cos d, which will give us it in degrees. So this will be somewhere between 0 and 180. And our sight cone, we said we're going to use 60 degrees. So we're just going to check if it's greater than or equal to 60. And that should give us our condition. Interestingly, we've done quite a few nodes here, but there's not a single bit that needs execution because it's all data that I'm processing here. So now we want to make this change depend not only on whether there's something in the way, but also whether the player's within that sight cone. So we're just going to AND these two booleans together. Boolean AND, connect that in there, and plug that into the output. So we're going to check that that's fine. Yes. So hopefully, if I've done all that right, this is going to work. And so we've got, where are you? So I've done something wrong because it can't see me. I can see you. Where are you? I can see you. Where are you? I can see you. I've got this inverted somehow. So I need to check what's going on. Yes, I've been checking whether the angle is greater than or equal to 60 degrees. I need it to be less than or equal to. So it's literally inverted it so that it's, I've been checking if it's outside the cone rather than inside the cone. Easy fix. And if you see what the problem is. So let's check that. So it can see me, I'm inside the sight cone. I can see you, where are you? So I'm moving out of the sight cone. Now it might be reasonable to actually have the character be able to see me if I was up close behind it as well. So you could add in a circle for detection if you wanted to. Which you could just do by finding the length of that vector between the two, which we're finding, and checking the length. But at the moment, so it's got this behavior. So when I'm hidden, I'm behind a block, she can't see over the block for some reason. I'm getting into the sight cone there, and if I go around here, I'm out of sight. We've actually not got a sight block, which was a block which is inside her sight cone. So let's just rectify that to demonstrate that. Move this block further out so that it can become an effective barrier. Right. I can see you hiding behind the block. Where are you? There we go. Right, so we've now got a situation where what she says depends on whether realistically I can be seen by the AI. So we're going to extend this further in the next video, but that's it from me for now.